So as you can see up here on the board, our learning target is to understand and calculate the concepts of limiting reactant, excess reactant, percent yield. Now, you'll hear this called limiting and excess reactant, or you also hear it called limiting reagent. Okay, so sometimes we replace the reactant with the reagent. So that's our learning target, our success criteria. We are going to be able to identify the limiting reactant and the excess reactant. You're also going to be able to calculate the amount of the remaining excess reactant after it has occurred. Now, like I said, the gentleman that was on the video did such a great job. Okay, he talked about cheeseburgers and buns and the meat and the cheese and showed you, okay, you got this much meat, you got this much cheese, you got this many buns. Which one runs out first? That's the limiting reagent. What do you have extra of? That's the excess reagent. And could you count how much extra you had? Absolutely. Okay? Absolutely. I think of this too as water. Okay? Think about water. I go out to Walmart's and I buy a case of water. Okay? I bought a case of water and I bought 2 boxes of the little packets to put in my water. Okay? Each of those 2 boxes have 8 packets in it. So I got 16 packets, right? How much water do I have in a case of water? 24 bottles of water. So what's going to run out first? My packets. Okay? So I'm going to use up all my packets. I'm going to have extra water. That is limiting and excess. My limiting is the packets. My excess is the water. Could you tell me how much water I have left over? Well, what's 24 minus 16? 8. I've got 8 waters left over. All right? That's all this is, folks. But when we start to throw it into chemical equations, okay, and do mass-to-mass problems, people get freaked out and can't do it. I don't know why. Okay? I don't know why. So what we're going to do here is we're going to work one of these. All right? Actually, I think we're going to work 2 of them. We're going to work 2 of them, and then you're going to have a problem to take home to do for Monday. So here's our first one. Go ahead and copy this into your notes. All right, as I look at this, it states that sodium bicarbonate reacts with sulfuric acid to yield sodium sulfate and it's also going to be carbonic acid. So, just to save time, there's my reaction. To balance it up, I'm going to have a 2 here. I'm going to have a 2 here. So there is my balanced chemical equation. Now, the problem here, ladies and gentlemen, is that it tells me in the problem that I have 40 grams of this reactant and I have 6 grams of this one. Do you think that 40 grams is going to react with exactly 6 grams? Probably not going to happen like that. Okay? So one of these is going to be extra. We'll have extra. One of them will be limiting. Now, what people want to do is they want to look and say, okay, that is the smallest one. That is the limiting one. That's not a true statement. Just because it's smaller doesn't mean it's limiting. If you do that, you're flipping a coin. It's a 50-50 guess. If you guess wrong, you're going to miss the entire problem. Okay? So what I like to do is I like to go through and calculate and actually confirm which one is the limiting one, which one is the excess. Now, does it matter which one I start with? It does not. I can randomly pick one, so I'm just going to randomly say I'm starting with 40.0 grams of NaHCO3, which is sodium bicarbonate. Now, what I'm going to do is I'm going to do a mass to mass, all right, because I have grams of sulfuric acid there. So I'm going to do a mass to mass calculation from grams of sodium bicarbonate, and I'm going to end with grams of sulfuric acid. So when I do that, I've already got all my numbers calculated just to speed things up a little bit. So 84.00661 grams of sodium bicarbonate is 1 mole of sodium bicarbonate. That's the molar mass. So my grams cancel. I've converted that to moles. Now I've got to go to my balanced chemical equation. 2 moles of sodium bicarbonate react with 1 mole of sulfuric acid. So my moles cancel. I've now converted that into moles of sulfuric acid. And I know that 1 mole of sulfuric acid has a molar mass of 98.07848 grams. So my moles cancel there. So when I do all of this math, I came up with a value in grams of H2SO4, and that value to 3 sig figs was 23.4. Now here's the key part. Here's where students struggle. What does that tell me? Well, it tells me that if I have 40 grams of sodium bicarbonate, for that to react 100%, I need 23 grams of sulfuric acid. Do I have 23 grams of sulfuric acid? No, I only have 6. So what is limiting this reaction? My limiting reagent is sulfuric acid. I'm going to have extra sodium bicarbonate. Now, I've identified my limiting reagent. Is that what I was supposed to do? And the answer, no. I wanted to figure out how many grams of sodium sulfate will be produced. So this guy right here, how many grams of sodium sulfate will be produced? So I'm going to do a mass-to-mass problem. And I'm going to start with my limiting reagent. Do I want to start with that 40 grams? No. Not all of it's used up. It's going to give me a bad value. I'm going to start with 6. I'm going to start with the 6.0 grams of H2SO4. And I'm going to do my conversion boxes, and I'm going to do a mass-to-mass problem, and I'm going to convert this into grams of sodium sulfate. So as I do that, I knew from up above that this is 98.07848 grams of sulfuric acid. That's 1 mole of sulfuric acid. So my grams cancel. I need to go back up to look at my molar ratio. 1 mole to 1 mole, correct? 1 mole to 1 mole. So my molar ratio is going to be 1 mole of H2SO4 is going to produce 1 mole of Na2SO4. So I've used my molar ratio now to convert that into moles of sodium sulfate. I want to define the mass, so I know that 1 mole of sodium sulfate has a molar mass of 142.0 0.04214 grams of Na2SO4. So my moles cancel. My final label then is going to be grams of Na2SO4. And when I did my math, it came up to be something like 8.69 blah blah. So it's going to give me, with a round to 2 sig figs, 8.7 grams of sodium sulfate. So what does that tell me? What does that tell me? It goes back up here, and it says that if I have 40 grams of sodium bicarbonate and 6 grams of sulfuric acid, I ought to make 8.7 grams of sodium sulfate when that reaction is done. Okay? So, is this somewhat of a lengthy problem? Absolutely. This is dealing with everything, once again, that we've done this far in chemistry. It's putting it all together. Now, we've got another one that we're going to work right here. So go ahead and copy this one into your notes, and then I'll work it. This problem states that if I have 35 grams of sodium metal and it is reacted with 35 grams of water, how many liters of hydrogen gas will be given off if this reaction is at STP? So I have STP, so I know that I can use the molar volume of a gas. Now, some things that I have to do. I have to go through and look. Sodium metal is reacting with water. I go back through and I look. That is a single replacement reaction. Specifically, it's a single replacement number 2. An active metal plus water yields a metal hydroxide and hydrogen. Now, I need to look on my activity series. Here is hydrogen on my activity series. Is sodium above that? Okay, actually, check. I'm not looking hydrogen, I'm looking water. Because there's a line that says reacts with steam and reacts with cold water. Sodium is above that line. So this reaction will occur. I need to make sure I check that. This reaction will occur. So I have sodium metal reacting with water to produce a metal hydroxide. My metal is sodium hydroxide and hydrogen gas. Now I have to balance that up. So if I put a 2 here, a 2 here, and a 2 here, that balances up the equation. So now I have my balanced chemical equation. I've got 35 grams of sodium, 35 grams of water. Doesn't matter where I start, okay? Doesn't matter where I start. So I'm just going to start with 35 grams of sodium. Now I'm going to flux, I'm not going to flux, well, I am going to flux capacitor that, but, I'm going to go from mass of sodium to mass of water. So I need to have the mass of sodium on the periodic table, which is 22.98977 grams of sodium. That's 1 mole of sodium. My molar ratio is going to give me 2 mole of sodium. It's going to make 2 mole of water. So my moles cancel now. Then I have to get this back into a mass. I know that 1 mole of water has a mass of 18.01528 grams of water. I get my moles to cancel there. Now, as I'm looking at this and doing math, I have a 2 over a 2, so I'm not going to do that. So I'm going to take the 35, divide by 22.98977, and then multiply that by 18.01528, and it's going to give me grams of water. Well, when I did that, it gave me to 3 sig figs 27.4 grams of water. So, if I have 35 grams of sodium, 100% reacts with 27.4 grams of water. Do I have 27.4 grams of water? Yeah, I got 35 grams of water, right? So this is, let me show you something new here. If I take 35.0 grams, that's what water, and I subtract 27.4 grams, this will tell me how much water I have left over, right? Well, I can do that. I got to borrow that 5 right there. So I got a 6 here. I got to borrow again. So I got 7.6 grams of water left. So that is the excess reactant. I have 7.6 grams of water left over. You're going to have to do some WebAssign calculations like that, telling you how much is left. All right? That's simply how I do it. So when this reaction occurs, when all 35 grams of my sodium used up, I should still have 7.6 grams of water left. Now, in my problem, I was asked how many liters of hydrogen gas at STP. So what I have to do now is I've got to take my limonene reagent, which was at 35.0 grams of sodium, and I've got to do a mass to volume because I'm trying to figure out liters of hydrogen gas. So I have that 22.98977 grams of sodium. That's 1 mole of sodium. My grams cancel. I need to go back and look at my molar ratio. 2 moles of sodium, 1 mole of hydrogen gas, or excuse me, 1 mole of hydrogen. So 2 mole of sodium, 1 mole of hydrogen gas. So now I've converted that into moles of hydrogen gas. Finally, I want to get the volume. So 1 mole of hydrogen gas is 22.4 liters of hydrogen gas. My moles cancel. So when I go through and I do my math here, I came up with a value that's going to be labeled liters of hydrogen gas. I came up with a value of 17.1 3 sig figs when I did my math. So this tells me that if I have 35 grams of sodium, 35 grams of water, I will produce 17.1 liters of hydrogen gas. I'll have 7.6 grams of water left over. Okay? Now, could I go back and figure out how many grams of sodium hydroxide? Could I go back and figure that out? Yeah, that'd be a different mass to mass. But I could go through and I could do that if I wanted to. Okay? Now, your homework, ladies and gents, your homework is going to be to work this problem. And it says homework problem for tomorrow. This is your homework problem, and it's going to be due in a couple of days, not tomorrow. Okay? So go ahead and copy this down and get working on this.